Hi, this video is going to take you through some of the sections of Lesson 9.4. Obviously, as you read this, we are talking about, again, extracting roots. That would be like square roots, cube roots, fourth roots, fifth roots, all of those things that we've kind of been looking at, as well as rewriting radicals. And again, radicals is just another word for like the roots. So we're going to be doing both those things. They're going to have rational exponents as we keep going forward. Rational exponents, again, are whole numbers or any fractions. So that's what we're going to see in this section. So the first thing we're going to do is we're going to turn the page 694 in our text. So take a minute, turn to 694. And on page 694, you start off with this first problem. And it says, previously we have rewritten radicals by extracting roots involving numbers. For example, that would be like when we took the square root of 50, we broke that down into a square root of 25 and a square root of 2. And we knew that the square root of 25 was 5. So we extracted it, as they're saying, and we had left with 2. So we were doing that involving numbers. In this lesson, we're going to explore how to do it if it actually had variables involved. And so we're going to do a few steps to begin with to figure that out. And so that's why we're doing several different values of n, different root values. So for this first example, we're going to let the value of n be 2. So that means we're actually taking the square root. And what we're going to do is we're just going to, again, figure out some function family association and graph it, and then write some equations. So the first thing they want us to do is if x is negative 2, they just want us to square x. And we know that if we square x, we get 4. The next thing they're asking us to do is to take the square root of the value we just squared. So square root 4, I get positive 2. So do the same thing here. Take negative 1, square it. 1. Take the square root of 1. 1. Square 0. Take the square root of 0. Square 1. Take the square root of 1. Square 2. Take the square root of 4. And we've created or filled in our table. So then if we go to our graph, we're going to graph the x values compared to, as they kind of show up here, compared to the radical value. So we're going to graph the point negative 2, 2. Negative 2, 2. Then we have the point negative 1, 1. We have the point 0, 0, 1, 1, 2, 2. And we see a graph for our first problem as looking like a V. And you may have learned in previous math classes that when you see a function that looks like a V, its function family, we haven't really discussed it this year, is an absolute value. So anytime that you have a graph that looks like a V, it's an absolute value. You've learned in previous math classes that that would be, again, equation for a graph, y equals the absolute value of x. These are straight up and down lines. So that's part A. Part B asks us to do the same thing. So I'm going to walk through part B with you as well. This time, instead of asking us to have n be 2, we're asking n to be 3. If n is 3, then we have to cube negative 2. Again, cubing just means we're taking that times itself 3 times. So negative 2 times negative 2 times negative 2, we actually get negative 8. If you cube root negative 8, we showed this in class last time, you actually get back negative 2. If you cube 1, negative 1 times negative 1 times negative 1 is still negative 1. And if you cube root negative 1, still negative, negative 1. If you cube 0, you get 0. If you cube root it, you get 0. If you cube 1, 1 times 1 times 1, 3 times, and then you cube root it, you still get 1. If you do 2 times 2 times 2, you get 8. The cube root of 8 is a positive 2. And we notice that these values are different from what we saw above. So again, we're going to create our graph by doing x and then using the radicals. So we're going to be at negative 2, negative 2. We're going to be at negative 1, negative 1, 0, 0, 1, 1, 2, 2. And so if we make our line for this, our line, or our graph is a line, so that's why we call this one linear. And we know that our equation for linear things from the beginning of this year is just y equals x. So what I'd like you to do is I'd like you to pause the video right now, and I'd like you to complete parts C and D. And you should start to notice a pattern as you're going through it. Again, remembering that when you cubed root something, it was taking that number, like -2, and multiplying it by itself 3 times. That's a terrible twos, I'm sorry. On the next page, when you look at questions C and D, you're doing the 4th root and the 5th root, so you're going to have to multiply that number times itself 4 times and figure out that value. And if it's a 5th root, then you'd have to do 5 times. So pause the video and try C and D. Hi, you should have finished your graphs of C and D, and now it's time to just talk about the pattern that you saw. So when you looked at the pattern, what did you notice? What were things that we saw? Well, I hope that you saw that for each expression, the root that we were taking and the exponent were the same. So I'm going to write that down. The root and the exponent were the same. What else did I notice? Besides that, I noticed that when you had even roots, what do we see? When the roots are the exponents, the root was even, what happened? When the root was even, it simplified, or we saw when it was even, it was an absolute value function. What happened when the root was odd? Well, I hope that when you saw that the root was odd, when it was odd, we had linear functions, like the 3 and the 5. So those are kind of 2 things that we're going to kind of keep thinking about as we go through it, and that's what they're kind of showing here. They're saying, okay, to extract a variable from a radical, here's my radical. It can be written as this. If you're going to take a root of something, you're going to get the absolute value when n is even. And you're going to get absolute value, or you're going to get a regular x when it is just a odd exponent. So now that kind of makes sense as they ask us in question 2, why is the 7th root of x to the 7th, why is it incorrect to say it's absolute value? Well, it's odd, right? So if this is odd tells me that it should just give me the 7th root of x to the 7th should just be a plain linear on x. So now my question is number 3. I want you to take a minute again, pause the video, and I want you to write down who in number 3 is correct. So read about Asia and Melissa and find out who is correct. So you should have came up, this is kind of shocking, they're actually both correct, because x squared is always going to be positive. So even if you took the absolute value of a positive value, it's still going to be positive. So because x squared is always positive, it's just like the absolute value. So actually Asia and Melissa are both correct because the absolute value of x squared is still x squared. So that's just the brief intro to section 9.4. What I'd like you to do next is I want you to look on the next page at problem number 2. And in problem number 2, it's asking you to go through and review all of your exponent rules that you've learned in previous math classes. And they show you the property, they show you the rule, and then you just need to describe what do you do specifically written explanation for each of these properties in the table. Once you're done filling out the properties, if you turn the page to 699, there are a whole bunch of items on there, just different equations that you should simplify. It says to cut them out. You don't need to cut them out. Just simplify each of them using the properties on this page as you go through that. And so that's kind of our first section of chapter or section 9.4. So again, fill out this table on page 698. After you fill out the table with your written, or sorry, 697, after you've written all of your rules in here, then on page 699, simplify each of those groups. When you're done, we will show, or we'll go through the answers for that, for this table as well as for the ones on page 2. Thank you.